Hello, viewers. Hello, my Kcse candidates. I am taking this opportunity to wish you success in your exams. And at the same time, I'm taking this opportunity to wish you a successful chemistry week with less panic. Chemistry is one of the easiest subjects, it is one of the most enjoyable subjects, and it is one of the subjects that gives you three opportunities or three chances just to prove your worth. You have a chance in paper one, you have a chance in paper two, and you have a chance in paper three. So, all those chances, my dear student, you cannot go wrong in all of them. And that is why I want to give you a small talk and just an encouragement as you are facing your beautiful chemistry week. So today I want to talk about familiarity with common laboratory apparatus expected in a chemistry practical. In my previous videos, I'd talked about a pipette, burette, and normal titration apparatus, how to read pipette, how to read burette, how to measure volumes and read them correctly. And I've also talked about how to differentiate colors of solutions and precipitates. Those are some of the skills that you need to have. Am I able to read volume? Am I able to fix my titration apparatus? Then the recording and all the others now follow, which I believe, my dear candidate, that you are well prepared for. Now, I want to talk about these two apparatus today, how to use a stopwatch and how to use a thermometer. And we want to enjoy this week. Chemistry weeks are very enjoyable. I don't want you to cry come Friday. I don't want to see chemistry KLB book being buried because chemistry frustrated you. I don't want to see chemistry books carried with flowers when students are wailing, doing mock burials of chemistry. Chemistry is a good subject. Chemistry is doable. Chemistry is a day-to-day life. We have chemistry at home, our food, and everything we encounter with, up to about 80 to 90% are chemistry. So we start. How do you use a thermometer? If I meet a thermometer on my desk, come Friday or any other day, how will I use it? Thermometers come in different types, or we have different types of thermometers. We have a mercury thermometer, we have an alcohol thermometer. Like with me here, I have an alcohol thermometer. The difference is in the thread inside. A mercury thermometer, the thread is silvery. An alcohol thermometer, the thread is colored. It can be green, it can be red, like mine is red, or any other color. So this thread rises and falls depending on the temperature you are measuring. If you are measuring a temperature that falls, you'll see it falling. A thermometer has a stem and a bulb. So when you're using a thermometer, ensure your bulb is safe, it's not broken, your stem is safe, and your column is continuous, is not broken. Okay, like my column is not broken. So when you're measuring your thermometer, ensure your bulb is dipped right inside your solution, and a thermometer measures readings to the nearest 1 decimal place. What do I mean by that? What I mean is this: when you measure a thermometer and you get a reading of 20 degrees Celsius, don't record it as 20 like this. Record it as 20.0. That is how a thermometer reading is recorded. Another thing you have to note down is that thermometer readings increase by 1. Here I have with me a thermometer reading that ranges from -10 degrees Celsius to 110 degrees Celsius. So my thermometer range should be in between. And the graduations on a thermometer increases by 1 unit every time. So if I'm at 20, the next stick is 21. The next graduation, that is that thing that looks like a stick, is 22, 23, 20. It moves in one unit, one whole unit, not with a decimal point. So if I'm at 20, the next stick or that graduation is just 21. The next one is 22. The other one is 23, 24, then 25. That is how thermometer readings go on. So increases with 1 unit. That therefore implies that any reading that falls in between, like if I have a reading falling between 30 and 31, any reading that falls in between can only be 0.5. So that when I'm recording a thermometer reading, I can only have 20.5, 0.0 or 20.5. These are the acceptable readings that should be recorded when you're using a thermometer. We don't expect you to record 20.1, 20.2, 20.3, 20.4. These ones we don't expect you to record. We have put an X. Why? Because you cannot read 0.1. That difference between one reading, one graduation to the other in a thermometer is only 1 unit. So there is no way you can convince me that anything that falls in between, like where the dot is, if the difference is 1 unit, it can be 0.1. So anything that falls in between the sticks can only be a 0.5. So either you have a whole number, which is 20.0, or you have with a decimal point if it falls between 20 and 21, which is 20.5. But you cannot have 20.1, 20.2, 20.3, 20.4, and it applies across. So with that in mind, I want us to do a simple temperature change measurement. I'm using citric acid, that one that we use at home to sweeten our uji. That's what I'm using as my acid. I want to carry a simple acid-base reaction to measure the temperature changes. My citric acid is here. I measured half a spoon of it. I'm using this as my spatula. And then I'm also using baking soda. I also used half a spoon of it, of baking soda. So I've called my citric acid solid D, and I've called my baking soda solid A. So I want to prepare a solution of solid D. How do I do that? So maybe the instructions, I'm talking about an exam scenario. Maybe the instructions are that you measure 50 cubic centimeters of water, pour in a beaker, and then you add solid D to dissolve. So I will use my 100 milliliters measuring cylinder. Remember, measuring cylinders also come in different sizes. We have 100 milliliters. The most commonly used ones are 100 milliliters measuring cylinder and 10 milliliter measuring cylinder. Whichever the examiner tells you to use it. So like for now, I want to measure 50 cubic centimeters with 100 milliliters measuring cylinder. 50 will be here. I'll observe correct reading of my volume when I've poured my water. So this is my water. I'm pouring it up to 50 meter mark, cubic centimeters mark with my wash water bottle. Observe all the measures that you need to take when you are doing your reading. Parallax, avoid reading okay, so that is 50 cubic centimeters. This is 50 cubic centimeters. So I pour it in my beaker according to the instructions. So my instructions are I measure 50 cubic centimeters of water, of distilled water, pour in a 100 milliliters beaker. That's what I've done. Then my next instruction is add all solid D. This is my solid D. I've told you it is citric acid, so I'm preparing a solution of it. Add all solid D. I've added all solid D. The next instruction is stir gently with the thermometer and record the temperature. So I'll stir gently until it dissolves. Stir gently until it dissolves. So don't stir like this. Students do that. You see, you'll be risking the bulb. Just be gentle with chemistry. Very, very confident. Stir, stir, stir as you look at your temperature. Look at the column of your thermometer. My column is rising slightly. I can see it is at 24.5. It is between 25 and 24. That is 24.5. That is my temperature reading. So if there is a column for me to record, which definitely will be, so there will be a column for me. If I'm to record that, then I'll be recording. So if this is the temperature of solution, so this is solution D actually now, because I've dissolved solid D in water. So temperature of solution D in degrees C, I've gotten it to be 24.5. That is what I record. It is 24.5. Then the next instruction is that I add all solid A. I add all solid A to my solution D. So my solid A is here, and solid A I've told you is bicarbonate of soda, that is a base. So I'm doing a neutralization reaction, determining the heat of neutralization. I'm not going to expound on that. You understand what I mean. In this case, I'm reacting an acid and a base. So I'm adding my solid A. You can see the reaction taking place. So as it takes place, I stir, and let's see what is happening to my thermometer reading. It is actually falling. It is falling. It is falling. It is falling. It is falling. You can see it falling. It is falling. It has come to 22.5. It has come to 22.5. It has fallen. There is an endothermic reaction. We normally have exothermic reactions, endothermic reaction. So this is an example of a reaction that brings a difference of temperature in a situation whereby the temperature falls. So an endothermic reaction. So my temperature, my thermometer reading is at 22. Actually, it has fallen further. It is falling even further. It is 22, not even 22.5. 22. Yes, so that is what I record. So if so say, for example, it is temperature of the mixture, that is after I've added in degrees C. So I'm getting 22.0. That is how I will record it. So I have temperature of solution D, which I got to be 24.5. Then temperature of the mixture after I've mixed them, 22.0. So again, there's a column that will ask you for the temperature change. We call it delta T. So if you see delta T, they want you to record the temperature change. Delta T is always final minus initial. This is your temperature. This is the final temperature. The temperature you get, whether it is low, the temperature you get after the reaction is your final temperature. The initial temperature is that one that you got just before you started the reaction. So whether it is lower, it is your final. So to get delta T, it is always final minus initial. So this one will give us a negative value. So in this case, my final minus initial is 22.0 minus 24.5. And that gives us what? That gives us negative 2.5. So you can work with your value. You know what it means when your temperature value is negative. When your temperature value is negative, it simply means that that is an endothermic reaction, and the system is absorbing heat from the surrounding. And therefore, your overall delta H value, if you'll be calculating your delta H value, that is delta H, which is given by MC delta T. If you will be calculating this, that is the enthalpy change or the heat change of the reaction, then you know that the value that you'll get, your delta H, should be positive. Should be positive. Whatever value, it should be positive. It will be positive. It will be positive. Okay? So I'm not going into all that calculation. What you know is that this is an endothermic reaction, absorbing heat from the surrounding. My delta H value, my delta T value is negative. Overall delta H value after all the calculations will be positive. So that is how you use a thermometer. How do I use a stopwatch? A stopwatch is this. Now, you can also be having yours, a wristwatch, depending if your laboratory does not have enough. The teacher can tell you to use yours, whichever you have. If it is accepted by the supervisors, it is not electronic, no more storage that can risk exam cheating, then you are allowed to use it. So either way, it is a stopwatch. So a stopwatch has 3 parts that are very, very important for you to know. So when you get your stopwatch in this form, it means it is not set. A stopwatch is set when it is reading like this one. This one is a set stopwatch. 0, then there is a colon, a full colon, 0, 0, then there are some other zeros. So a stopwatch is in minute. So the first 0 is minute. The second 2 zeros are seconds. Then the last 2 zeros are milliseconds. So if you find it in this form, you can ask for the assistance of your teacher to reset it, or you can reset it alone. There is this button that is for start, stop. There is the mode. There is the reset. Some stopwatches don't have the mode button, or they only have the start, stop, and then the reset. Whichever way, you can reset your stopwatch. Just manipulate between the buttons. Like I've done, until you reset it. So my stopwatch is set. So you see, if I press this, I've started it. You can see it running. If I press this, I've stopped it. If I press, I have started. I keep it moving. If I press, I've stopped it. If I want to reset it, I press this, reset. So you'll be given instructions on how to measure your volumes, how to do ABCD, how to start your stopwatch. And you should know the start, the stop. Always start using your stopwatch when it is in this form. And how do you record your stopwatch readings? When you are recording your stopwatch readings, for example, say I have doing an experiment and the experiment is running. Maybe I'm supposed to be recording my time, whatever is happening in the reaction, after an interval of 20 seconds. So I let it run as the reaction proceeds. So my eyes are there. At 20 seconds, click 20 seconds, pop, you record your reading. You don't stop. Just record your stopwatch, record the time. Allow it to go to the 40th second, record, and continue recording until you reach the time when you complete your table. How then, if it is at the 40th second or the 41st second, how do I record this? Suppose there is a reaction that you've carried out and you are at this, you've gotten this, you are at this part. You have a situation where you have 0, full colon, 41, 22. You have something like this. This is what I have. 0, 41, 22. That is what my stopwatch is reading. So if my stopwatch is reading this, then it means that I have 0 minutes. The reaction has taken 0 minutes, 41 seconds, 22 milliseconds. How do I record on my table? Most tables always want you to record or will always instruct you to record your time in seconds. Most chemistry record time in seconds. So if your time is recorded in seconds, then when you are recording your time, then your time should be 41.22. Ignore this. So the correct recording should be 41.22. 41.22. That is this time. Now, suppose the reaction proceeds until you get something like this. It goes, let's have a situation whereby the first figure is, the first digit I mean, is not 0. So let me allow it to move so that that first one is not 0. Like it is moving now, it is already 1. So suppose it moves all the way to this. So something like this. Let me stop it at that. You can see it. It is reading 1 full colon 12. Then there is 35. It is reading like this. 1, 12, 35. This is what my stopwatch is now reading. Now, how do I record that in seconds? This means that the time taken for the reaction is 1 minute, 12 seconds, and 35 milliseconds. If your table is recorded in minutes, I mean, is you are recording your time in seconds, then you have to convert your minutes into seconds. So how will you record this in your table? What you do, you know that 60 seconds are in 1 minute. So your seconds, so this will be 60. So you'll add 60 to 12 to give you the total number of seconds. So you'll be having 60 plus 12, that gives you 72. That gives you 72.35. So that is what you'll have. So 1 minute, 12 seconds, 35 milliseconds on my table should be 60 plus 12, which gives me 72 seconds and 35 milliseconds. So with that, I want to believe that you are confident enough. I really, really wish you success. I really, really wish you a beautiful chemistry week. And we shall revisit after this exam. Don't bury chemistry, my dear students. Enjoy chemistry and have a very, 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 very fruitful chemistry week. Thank you.